Alrighty, we are picking up where we left off in the notes. What lesson is this?
I don't have
3, 4.
3,
4. Okay, we were talking about how we could solve exponential equations. So how we solve equations when our variables up in the exponent spot, right? And we use logarithms because they are inverse operations. All right, we kind of like barely went over this one. So this one's a little bit trickier to see. I'll erase this step. But this is technically an exponential equation that's in what we call like quadratic form. Okay? So I basically showed you how we could rewrite. I can start over actually. We could rewrite 3 to the 2x. That's really like we have 3 to the power of x being squared. Because when we have a power to a power, we multiply the exponents. All right, and then I have 3 to the x. So essentially, let me get a little box here to show you this. All right, let me do this quick. Okay, so picture we have this. This is what I mean in quadratic form. We have something being squared plus that something minus 2. So picture it's like an x. If I have x squared plus x minus 2, you would factor this, right? Okay, so that's what we're going to do here. So then I kind of drew in like these coefficients. You really have a 1 here and a 1 here. So you're thinking what multiplies to negative 2 and adds to 1. That would be negative 1 and positive 2. And then normally you would just put, x there, but I don't have x. I have 3 to the x. So this one technically like factors. Okay, does that kind of make sense with the boxes?
Yes, but I don't like this.
Oh, okay, that's fair. All right. So now, zero product property, set these equal to 0, and solve. No problemo, Miss Henchurch. Here. We don't even need logs to solve this piece, guys. 3 to what power would give me 1? 0, right? Or you could take log base 3 both sides. Either way, you're going to get 0. Okay, there's one solution. 3 to what power gives me negative 2. Right, we know our domain for exponential functions is only 0 to infinity. There's nothing I could plug in for x that would give me a negative value. Now, if you didn't recognize that, what you would normally do is take log base 3 of both sides, because 3 is my base in this exponential equation. And if you try to take log base 3 of negative 2 in your calculator, it's going to say, error. Usually it says like domain error, non-real answer, something funky like that. So this one, there's nothing here. 0 would be my only solution. Okay.
Oh, I see now.
Yes. Number 2 is really similar. I see e to the 2x, which I'm going to do that little kind of reverse exponent property. Hey, I recognize that. That's really e to the x that's being squared. Plus 4 e to the x minus 12. And this is kind of looking like it's in quadratic form, but this time my box is e to the x. I want it to show. There we go. All right. Pretty different. There we go. So again, think of this as you have like y squared plus 4y minus 12. How would you factor that? What two numbers multiply negative 12 and add to 4? Negative 6 and 2. Yep, so you would do y minus 6 and y plus 2, but we don't.
Plus 6 minus 2.
Yeah. Oh, yes. Is that what you said, Connor?
Make it tally
Gosh, Connor. You just 6 and 2.
Oh, got it. Good catch. Positive 6, negative 2. Oops. I think I meant to do negative 4. Okay, it's fine. But we don't have y. We have e to the x. Okay, so it's factors. All right, set these equal to 0. Here we have -6. We know that won't work if we try to take natural log of both sides. Since we have base e here, you would see can't take the natural log of -6. This one, I would take the natural log of both sides. That undoes that base of e. All right, so to actually get x equals the natural log of 2. Let's get a rounded answer here. Remember, you just have that ln button in your calculator. Natural log of 2 is about 0.6931. Okay.
Spooky.
Feels very
Nice
quiet,
answer.
doesn't it?
Sure is. If only we were running 2 decimal.
Okay, folks, that's all. That was all exponential equations.
That's all we gotta do today?
No, now the second half of the lesson is solving logarithmic equations. So equations that have logarithms in them.
Try.
All right, here's your exploration.
Can you take the log of the log?
No. You're not gonna use, that'd be like, if I have 2 times x, I'm gonna times both sides by 2.
Sounds like
You're
a
gonna do the
great
inverse
idea.
operation. Okay. See if you can figure out how to solve these two.
Divide by log.
Cannot divide by logs. No.
Killing cats.
Definitely cannot. Because logs is not the same as multiplication.
Wait.
I just said 6 and 2. I didn't say
Yeah.
Got it.
anything.
Nice. Yes.
Let's go.
Wait, how
Did you get it?
I don't know.
do I?
It's like back to like 2 units before this.
Yeah. Mm-hmm.
Switch it to the other way or whatever.
That
Sure.
is one way you could do that.
Got X on.
Do I know how to do the other one? No, but
I didn't know there was other ways to do it.
Because it's log base 5
This is what I
x,
did
not
for
like
the other
times
one.
x.
Wait, no.
I like your idea though. We're trying to take off the layers.
Wait, no, shit. X should equal 5.
Okay.
just wait.
Seeing some good stuff. So, Ashton, I'm going to share out your idea. Shout out on my YouTube channel, Ashton Street.
Oh, wow. I might get 3 subscribers now.
He said, let's rewrite this in exponential form.
I
think I
got
saw
it.
That's what I did.
What?
I still don't know.
That's what I thought.
I just rephrased it. Okay. You guys know how to do that. This is in log form, obviously. This is saying 5 to the power of what?
1
Equals.
X.
So x would have to be 5. Okay. Another way you could do this, and I'm going to show you this strategy on number 2. What's the inverse operation of logs?
Divide.
No. That's multiplication.
Exponential.
Exponential. Thank you, Tyson. Exponential.
You're too smart for this class.
Right? And we used logs to take off layers around exponents. So you can use exponents to take off the layer of a log. They're inverse operations. They undo each other. So this is log base 3. What I could do is take a little 3, base 3, and raise both sides as exponents, and that would get rid of that layer. And I'd be left with x plus 2 equals, this is not 3 times 2, it's 3 to the power of 2 equals 9, which would have been the same thing if you rewrote this in log form, right? And we get 7.
What?
Oh my Lanta. It's
What's
genius.
the- We'll do more. Don't
I
worry.
ain't doing this
That
way.
again.
This was your exploration. We're gonna do way more examples. Don't worry.
Yay.
This was. Let's see if you can figure it out on your own. And you did. You did. Exactly. That's why it's called exploration.
How come it's 3 to the second?
What's the base on this log?
Oh.
So you use 3 as a base and raise both sides. Okay, don't worry, you guys. We're gonna do more examples. It's cute though that you guys really consider. Okay. All right, number 1.
Got that critique.
Now you technically could do the strategy Ashley came up with. You could technically rewrite these in exponential form every time. Like you could do that, just like you could do that with exponential equations too. But it's just easier, as in the general rules of solving equations, just to take off the layers and understanding the relationship between logs and exponents. All right, here. That log has a base of what? 10. Why don't you tally the number of times Connor's wrong?
Hey, I said 10. You said 1.
X equals negative
1
6.
times 10.
10.
1 times 10.
So you're gonna take a base of 10, and this is weird because you've never done this before. You're gonna take a base of 10 and you're gonna raise both sides of the equation as exponents. Okay, picture that. I'm doing 10 to the power of log 10. I'm exponentiating both sides, is what that's called. Exponentiating both sides. And you can do this in equation as long as you do both sides.
Oh, geez.
And again, that would take off this layer, that would undo the log. Remember, if they have matching bases, they cancel each other out. You'd be left with x plus 6, 10 to the first, 10. All right, now, before we go any further, I need to tell you something important. When we have logarithmic equations, logarithms have restricted domains, right? When we graph these, they had vertical asymptotes here, and we had our key point here at 1, 0. And remember how our domain was only positives? All right, now with exponents, we didn't have to worry about this because the domain for exponential functions is all real numbers. But since we have a restricted domain for logarithms, kind of like if you solve equations with square roots, remember how sometimes you get extraneous solutions? Because when you go to plug them back in, you end up square rooting a negative number. Do you remember doing that in algebra 2?
Yes.
Okay, same with this. You have to go back and make sure it fits in your domain. So all you have to do, folks, is look at what you're actually taking the log of, the argument, I like to call it. I'm taking the log of x plus 6. So all you have to do is make sure that when you plug x in there, which is 4 plus 6, as long as that argument is positive, you're good. You don't even have to check it any further. I mean, you can if you want to check your answer like a good math student would. But all you got to make sure is that that is positive, and then you know it's not extraneous. You know that that would fit in your domain, right? We can take the log of 10, obviously. And the log of 10 with base 10 is just 1, because that's asking 10 to a power of 10, 1. Okay. So when you're solving log equations, make this little note. Check domain.
Being hasty with it.
Okay, and we know this because we tried to type in the log of like negative numbers, and I showed you it said error. Okay. Here I have log base 3 of 3x minus 1. So again, picture this as you have like 3 layers around your variable. The first layer you have is log base 3. The second layer is a minus 1. The third layer is a times 3. You guys know how to do those ones. How do I get rid of the log base 3? Using its inverse. Exponents. Yep. 3 is my base. So I'm going to raise, exponentiate both sides with a base of 3. And again, that is important that that's 3 squared and not 2 to the third. That undoes that log base 3 layer. And then I get to here. 3 to the power 2 is 9. And then you guys have been doing this for a long time, taking off the other 2 layers of inverse operations with adding, 10/3 division. All right, make sure when you take 3 times 10/3 minus 1, is that going to come out to be positive?
Yes.
Yes. Okay, then we're good. That's positive. We're good. Check. Okay. Let's try natural log. What's my base on natural logs? E. So I'm going to raise both sides using what as my base? E. Now get rid of that.
Ciao.
Now, E squared, we're just going to leave this exact. We're just going to call it E squared. It's a number.
Over 3.
You don't really need these parentheses. I don't know why. Then we just divide both sides by 3. So you could either write this as like 1/3 E squared, or I'd probably do like E squared over 3. Doesn't matter. In our calculator, let's go ahead and do that. So we have E squared divided by 3. Yep, we're just going to take the 4 decimal places. And again, guys, E's irrational, so you can't write that as a fraction unless you keep it in terms of E. Okay. All right, now obviously you have a positive number here, so if you take 3 times that number, it's going to be positive, right? And you don't even really have to write that out. You just have to remember to check, okay? I'm okay with you not like showing me that. You just have to remember to do it.
So do you always want that exact answer like that, or can you leave it E squared over 3?
I don't know what I want yet.
Good question.
I think I'm gonna. I don't know.
All of the above.
I think I'm gonna want the decimal answer.
If we can prove that we can get the decimal answer, then we don't.
I don't know what I want yet. I'll look back at my like quizzes and stuff. I'll let you know. I'm probably gonna have both.
It's not a huge name this time.
Okay. Ooh, good problem. So here I have log base 5 on both sides. Now, what we can't do is raise both sides, exponentiate both sides yet, because I have this 2 and I have this 3 in front. So I'd be like, oh, can I divide both sides by 2? But then I'm gonna have 3 halves, and you're like, well, how am I gonna get rid of that? Log properties. If I have a number in front here,
Where's the X in a second?
we can put them back as powers. Yeah.
Fancy.
Right.
Oh,
It
my
clicked.
university.
My brain clicked.
Isn't it
That
cool how
never
math
happens.
just builds? We're technically kind of condensing this, if you will.
64.
No, it's less good. What's 4 to the 3rd?
64.
Oh, there we go.
Okay, divided by X.
Okay,
Nerd.
now we can exponentiate both sides using what is my base?
5.
5. Good, yep.
Boom. Square root 64.
Boom, boom. Oh, snap.
X equals 8.
Well, technically we need plus or minus.
Yes,
Minus
we
8.
do.
No,
What?
one of them is extraneous.
Why? Oh, wait,
Look back
you're
here.
right.
That is true.
Yes, good. We can't take
So
the log
it
of
is
negative 8,
I was right.
so it's just 8. But you should technically be showing like this stuff in your math, because with our algebra we do get plus or minus, but just make the note up here. Obviously when I take the log base 5 of negative 8, that's not greater than 0. That's extraneous. You can write that here if you want. Negative 8 is extraneous. Okay, good job, guys. Okay, I have 2 for you to practice. Aren't these fun? I like log equations better than exponential equations. All right, you just practice these first 2. And don't move on any further.
Yeah, I thought that's what it was. Sure.
27 to the power of -1 is not -27.
Oh.
I
Wouldn't that be square root 27? No. 1/27.
Technically, you can't leave that negative out there. You have to put it back. Anything that's in front, you have to put as powers. Otherwise, you can't exponentiate both
Oh,
sides.
you can't make it negative. It's just not.
No,
oh I didn't.
because it's not -27. It's 127.
Wait.
It's a power. It's not 27 times -1.
I did.
1/27.
Wait.
Yes, sir.
No. I don't.
Yes, folks.
Okay.
1/3.
Anything that's in front, you have to put as powers.
You do 1/3.
Otherwise, you can't exponentiate both sides. So x cubed 27 to the negative first. Then you can, once you have
I
no
can't really focus.
numbers in front.
Oh, I see.
Oh yeah.
Yeah.
Yeah, I'm stuck.
Cube root both sides. Do we need plus or minus with cube roots?
Yeah,
No.
No.
What are you talking about? I said no.
Yeah, no.
I got it.
All right. So when I obviously plug in 1/3, that's good. That's greater than 0. Same with this one. Both are positive, greater than 0. Okay. Everybody good with those?
No, but okay.
So technically, in number 2, we had to like condense the log before we solved, right? All right. So if you have something like this, where you have like 2 separate logs, you have to condense it first before you can exponentiate both sides.
You could minus a log of it.
But you don't want to do that because then you have like 2 minus log. So let me show you what you can't do, what some people are tempted to do. Like, oh yeah, let me just like raise both sides with the base of 10 or power 10. But you can't.
On both sides, it's 2.
Yes, exactly. You can't do that. So using our log properties, just like with the power ones, we're going to condense these logs into 1. And what operation would I do?
Multiplication.
Good. Yep. Okay, and you don't have to write that out. If you want to just go ahead and multiply them, you can. That's x squared minus 21x. It's kind of like, you know, in algebra, if you have 2x plus 3x on both sides, you want to add the like terms. You want to simplify first before you start taking off the layers around the variable. Same idea. You want to combine your like terms first, and now we can start taking off the layers around our variable here. This is base what, folks? 10. So I end up with x squared minus 21x equals 100. Not 20. Exponentiating both sides. I'm left with a quadratic, so I'm going to factor this. This does factor, negative 25 and positive 4. All right.
4 is extreme.
Negative 4 is extreme.
Wait, so how can we circle it?
I'm not done.
Patience.
Yes. So there's algebraically what we get here, and yes, this one. Cross it off. Extraneous. Now, guys, every time you get a negative answer doesn't mean it's going to be extraneous. If your equation was this, and you get a negative x, that would work in the domain, right? So you have to be careful to not just assume, oh, negative, it's automatically extraneous. You have to go back and check, and obviously this one is just x, so if you get a negative answer, yeah. But just be careful with that to not jump to conclusions too quickly. Check your equation. Oh, look at this one. All right. So my left-hand side, I just had the natural log of x plus 5. Over here, I see some condensing I can do. And again, we have to do that first before we start taking layers off. I guarantee at least one person will do this. Try to raise everything with the base of e. You can't do that. Don't be that. Don't be that person.
I want to be that person.
Don't do it. All right. So here I would have to divide, since I'm subtracting those two separate logs. Okay. Now that I have everything condensed on each side, now I can start taking off the layers. So I would exponentiate side with base what? E. Good. Okay. Now technically you guys solved equations like this before where I gave you the same log on both sides and I was like, hey, use common sense. If you have the log of something on one side and the same log of something else, obviously the insides have to be equal to each other, right? But technically, this is y. Like you're really taking off those layers. All right, to solve this, I would times both sides by, well, you could either you could cross multiply if you want, or times both sides by x plus 1 to get rid of that. Or you could cross multiply, give a proportion here, whatever makes more sense to you. All right, over here I'd get x squared, let's see, plus 6x plus 5.
Yeah.
Yep. Over there at x minus 1. Wow, I gave you some nice easy factoring ones with ones in front. I think it makes this harder.
What timing nice.
Okay, so this is factoring in x plus 3, x plus 2.
Wait, where?
That equals
Never mind,
5.
never mind.
You good, Jackson?
Oh, never
Yeah, I'm good.
Okay, algebraically I get -3 and -2.
Neither one.
Correct. Good job, guys. So obviously, just looking at this first one, well, technically, if I plugged it in this first one, those would both work, right?
Yeah.
-3 plus 5 and -2 plus 5. That's really positive. Yep. Check the second log. No solution.
No soul. No soul.
No soul. Sure.
And one of those is a minute.
Okay.
No soul.
Oh, we're done.
Huh?
What do you want?
It's a bag.
There's like no bar.
All right, you guys try these two, and then we just have a couple word problems.
I don't know
I
how
don't know
to
these
read
two
two.
bags.
Condense first. Condense first. You got it.
I don't know how to condense.
Sounds like
Comedy.
oh, I got it. Stop. I got
Oh, what the freak?
12 for the first.
I got kind of close. I got -12.5.
Yeah, so Jackson.
Oh, I forgot to. Yeah, I did 10 squared. So we cross out the log.
Oh, got it. That's okay. That's why we practice.
Okay, wait. Okay, question.
Make those
So how
mistakes
come
now.
we didn't square that 10?
Because it has a log on this side.
Oh, okay.
That's what I-
Yeah. Good question.
The second one. is
Make
the
mistakes now, and
fractions.
then you can
I'll add mine to the board.
fix it later. Okay. Do we need more time on number 2? Ooh, number 2. That's a little bit.
Can you tell me if I'm right?
Oh my gosh.
Because I am not confident. Jeez,
Yeah,
ridiculous.
Well, that should be 48x.
Yeah, it should.
And then that's gonna.
Am I right?
Nope, got it wrong, baby.
Yes, but negative 3 halves technically works.
It technically
Oh,
works.
it does work.
Yes.
Wow.
Yeah,
Is there a negative
Wait,
4?
I did not get this as a solution.
I think everything's
That was
positive.
me. That was silly.
No, don't
Oh,
actually.
yeah, okay.
You just get the same answer twice, but
You just write so far.
yes, I would divide both sides by negative 4. Or factor out negative 4 first. You're good so far. Yes? Okay, don't worry, I'll do it on the board. Condense first.
Yeah, you should do that on the board.
Condense first.
You should use Bailey's as an example.
Yeah, I should.
They're so smart.
Nerd.
Okay, so you should have gotten negative 16x squared minus 48x
Yeah.
when you condensed. Oops.
Makes sense.
All right. Then you should have exponentiated both sides with a base of 6. Which gives me 36 on the right-hand side. All right, now we factor this. So I personally always like to keep my first term positive, so I moved everything over to that side. And then everything's positive. You don't have to, though. I also, and again, I know I obviously didn't teach you how to factor, but I also, before I even try to factor, like, methods, I see if there's something I can divide out when I'm solving equations. So I divide it out of 4.
Yeah, I haven't done it yet.
Yes. And you can do that with equations, not when you're factoring instructions, but you can do that with equations, and then it just gives you smaller numbers to work with. Okay, either way, it should factor to this. And if you had a 4 out in front, that's fine. But that's obviously not a solution. We get negative 3 halves from both factors. It's not extraneous. Because when I take negative 16 times negative 3 halves, that's positive. And negative 1.5 plus 3, that's still positive. Okay. If you understood the log part of it, that's good. This part was new for us. This part's revealed, right? This part's algebra. That part's pre-calc. Okay. Now I just have a couple application problems to do here. And we're going to start with the exponential one. Actually, they're both exponential. Okay. So the number n of bacteria present in a culture at time t in hours obeys law of uninhibited growth. Basically, they're giving you the equation here. N of t is, we have 1,000 e to the 0.01 t power. Okay, what type of equation or what type of function is that?
Exponential.
Exponential, because the variable is in the exponent spot, right? That's an exponential equation. If we were to graph this, it would be x. They're telling us it's exponential growth. The number of bacteria is growing exponentially. Determine the number of bacteria at t equals 0 hours. Now you could go through and like find when t is 0, like algebraically. But this is really asking you, like, what is your initial amount of bacteria? And looking at our equation here, it looks like 1,000 is our, like, initial amount. Really asking you for initial amount. Okay, but obviously anything to the power of 0 is just 1, so we just get 1,000 bacteria. But this number in front here, guys, this is always going to be your y-intercept, your initial amount for exponential equations, right? The number in front, that's always going to be like your initial amount, or you could say your y-intercept. Because when you plug in 0, whatever your base is, anything to the power of 0 is always going to be 1. So that number in front is always going to be that initial amount. All right, what's the population of bacteria after 4 hours? Okay, we can do this. That means we want to plug 4 in for my time and for my t. So 1,000 e to 0.01 times 4. Okay, obviously we need our grapher for this. Let's just round to the nearest whole number of bacteria. 1,000 e, just like when you're doing the PERT equations, keep this all in the power. 0.01 times 4. And we'll round that up to 10,041 bacteria.
Not 1,021.
Yeah, did I say 10,000? Sorry, I meant 1,000. That's not really a mistake. That was just. Okay.
No,
Yeah, 'cause you never make mistakes.
It is.
Amen.
Okay. Now that you probably, I mean, you didn't know what E was before that, but that you could have probably figured out before this lesson. Here's what's new for us. They want to know when will the number of bacteria reach 1,700 or 1,700. Yes. So we need to figure out when this equation, when my number of bacteria equals. Nice. And obviously it says when, so we're solving for time. What type of equation is this? Do you see a log in there?
No.
It's an exponential equation.
It's an ln.
Okay, so we're probably gonna have to use logs to solve. But first thing I would do is get rid of the 1,000. So divide both sides by 1,000. Get rid of that.
Yes.
This is an exponential equation, so this is back to basically what we were doing like Friday. We get 1.7. Okay. Now in exponential equations, to undo base of e, we would use log base e, which is natural log of both sides. Okay, that would undo that base of e. So the natural log of 1.7, which I'll figure out what that is in a second, equals 0.01 times my time. So then I would just divide both sides by 0.01. Okay, let's just do decimal here because obviously if you told me, oh, it's a natural log of 1.7 over 0.01 years, I'd be like, I don't know what that means. Give it to me as a decimal. Natural log of 1.7, close that. Divide that by 0.01.
Hours.
Hours, yep. Why did I get a different?
Did you close it out? Did you do it together?
Oh, God.
I got
Sorry.
Everybody get this?
Yeah.
Okay, great. Let's just say 53.1.
What if you didn't round right away?
What'd you say? Sorry.
You didn't round right away.
You rounded
You did.
right away.
Well, yeah, like with 1.7,
Yeah.
you might have kept it in fraction. Of course,
I get like-
you get 1.7.
I got like 60
Who knows?
something. I don't know. I also stole this problem for something, so I probably just left it wrong. Okay, anyways, doesn't matter. One more. Perfect. One more, and then I put a couple like challenge problems
Ooh, we're gonna do tomorrow in class.
if you want to try them. Or we'll do them as a warm up tomorrow.
No,
Okay.
no.
Last one here. An amount of $500 is invested at an annual interest rate of 6.75%, compounded continuously.
Oh.
Ooh, continuously.
Hurt. How long will it take to double your money? All right. So you see compounding continuously. which is PERT.
Yeah.
We know our principal, the amount we deposited is 500.
Could you use 1,000?
Say it again.
Never mind. I said, could you use 1,000?
That's what we're gonna use, yeah.
Probably.
Yep, exactly. R, I'm just plugging in what I'm given so far. 0.6, 0.06
675.
T. You don't really need parentheses either. You can if you want to make sure you keep it all in the power. So yes, Megan, you're exactly correct. We want to figure out how long will it take to double the amount of money. So if 500 was the deposit, we want to figure out our time. How long would it take to get double 500, which is 1,000? Yep. Good. Okay, another exponential equation with base b. So divide both sides by 500, taking off the layers around my variable. I get 2 e to the 0.06. All right, what would my next step be? Natural log. Thanks, Bailey. Natural log both sides. This is an exponential equation. Very similar to how we solved the last one. Divide both sides by that 0.0675. All right, somebody give me that number.
10.3.
10.3. Time is years.
Years.
Wow.
Nancy.
Crazy how that works.
Okay, perfect. So if you want to try these two on your own,
Oh.
you can. If not, we'll do them as a warm up. They're just a little bit more challenging exponential equations. Tomorrow's a work day. Quiz over 3-3-3-4 Wednesday. Oh,
Very well.
I had 3 done. Like, I got 3 4
I'm having you ready for it.
Right?
That would be a bad idea.